All right. This is Math 123, Lesson 51B. I'm Jeremy Nally. And to get the most out of this recording, make sure that you are pausing the video and attempting to do the problems on your own before you watch me do them. Okay. All right. Solve the proportion for the variable, round to the nearest tenth if needed. So I have let's change colors here. So I have 14 over x is equal to 4 over 6. And we're going to use a trick called cross multiplying. So what that means is the 4 and the x are going to go together, and the 14 and the 6 are going to go together. So I'm going to write this as 4x equals 14 times 6. Okay, so I have 4x is 84. And then I'm going to get the x by itself by dividing both sides by 4. So I have x is equal to 21. All right. A x over 191 is equal to 89 over 91. And using the cross multiplying trick, this turns into 91x equals 89 times 191. I'm going to divide both sides by 91. And I end up with, well, let's see. I'm not going to do that one in my head. Not at this time. Well, I wouldn't do it during normal business hours anyways. Okay. Did we give any specific rounding rules? Nearest tenth. Okay. So 186.8. So cross multiply and divide. Cross multiply and divide. That's how we solve a proportion in Math 123. Cross multiply and divide. All right. While on a spring break trip, a group of friends burns 12 gallons of gas in the first 228 miles, then stops to refuel. If they have 380 miles yet to drive and their SUV has a 21-gallon tank, can they make it without refueling again? All right. So let's set this up. So let's do miles, gallons. So they went 228 miles and it took 12 gallons. Now, there's actually two ways to do this problem. So they have 380 miles yet to drive. So then we need to figure out what X is. So how many gallons of gas do they need for that? Well, cross multiply and divide. So this is going to be 228 times X equals 380 times 12. And then we divide by 228. So we get X is what? So I get exactly 20. Now, so that what that's saying is it's going to take 20 gallons of gas to drive 380 miles. But they just put 21 gallons in their tank. So we see that since this 20 is less than their gas tank, that means the answer is yes. Okay. Now there's an alternative way. So what if you didn't set it up like that? What if you set it up this way? So miles, gallons. You did the 228 over 12. Or if you, when you were trying this, you did 12 over 228 and you did everything else kind of upside down, that's still correct. Okay. But now I saw that 21 gallon tank and I put 21 gallons. And now we're looking for how many miles can they go on 21 gallons. So we still cross multiply, but now we're going to have 12y equals 228 times 21. Divide that by 12. So then we get y is what? So I get exactly 399. So now we say, well, their 21 gallon gas tank will take them 399 miles. And we can see that's greater than the 380 that they need to go. So the answer is yes, they can make it. Hey, how about that? We did it two ways and we got yes either way. So if if you started by plugging all of the numbers into the proportion and you got something, well, there's nothing to solve for. Well, you did it. You didn't plug it in quite right. Now, there there isn't an extra number. All of the numbers actually get used. Three of them will get used in the proportion, and then the last one that doesn't get used in the proportion gets used as a comparison. So you're seeing, oh, well, is this smaller than what the gas tank holds, or is this more miles than I actually need to drive, depending on how you look at the problem. So there's more than one correct way to do this, is my point. Do you need to do it both ways? Absolutely not. As soon as you figure it out, you're done. Okay. I'm just showing you both ways because who knows how people, do things sometimes. I've had different people do it different ways. As part of a research project, a biology class plans to estimate the number of fish living in a lake thought to be polluted. They catch a sample of 37 fish, tag them, and release them back into the lake. A week later, they catch 80 fish and find that six of them are tagged. About how many fish live in the lake, round to the nearest whole number. This uses ideas about sampling, random samples, and probability. So let's go ahead and set this up. So we have, let's say, tagged to total. Okay. So initially, they catch 37 fish, tag them, and toss them back in. So that's 37 fish out of all of the fish in the lake. So that's 37 to the absolute total that we're trying to find in the lake. So now when they catch that random sample of 80 fish, so that's 80 fish total in the sample, six of them are tagged. So that's how we're setting this up. So the idea is that the fish have had enough time to randomly go around in the lake. So if you catch a bunch of fish, you can look at that proportion of tag to total and make an assumption about the total number of fish in the lake. So that's all we're doing. We're estimating. Okay, so let's cross multiply that. So 6x equals 37 times 80. Then we divide both sides by 6. So we get x is what? Oops. So I'm getting about 493. Okay. A small college has 1,200 students and 80 professors. The college is planning to increase enrollment to 1,500 students next year. How many new professors should be hired to keep the ratio of students to professors the same? So students to professors. So currently it is 1,200 to 80. They want to go up to 1,500. Okay, so cross multiply that. So we have 1,200x equals 1,500 times 80. And then we're dividing by 1,200 on each side. And I get x equals 100. So now that's how many professors that they have to have. So now the question was how many should be hired? So then I'm going to take 100 minus how many are currently there, which is 80. So 20 need to be hired. Okay, so that one's a little bit tricky because you'll get to that 100 and you'll feel so accomplished, and then you'll forget there's just a little bit extra to do there. You just got to figure out, oh, well, then there's already 80 there and they're going up to 100. So how many do they have to hire? Well, I just subtract them. Okay, so rule of matching parts. You've seen me using it already. I have a bag of apples. There are 3 green apples for every 5 red apples. If there are 24 apples in my bag, how many are red? If I set up a proportion as shown, will it result in the correct answer? So let's see, that's on the left-hand side, that's green to red. On the right-hand side, that's total, and we were looking for red. Now we want, green's not really supposed to be in the picture here, right? So what's going on? What is the mistake? Well, there's definitely a mistake. So red is not across from red. No. So red reds don't match up. And we can see there's a green total on the left-hand side is missing. So kind of like 3-ish things that are wrong with it. So now if we're setting this up correctly, we will write down red to total. And write down our proportion. So 5 red, and then if there's 3 green for every 5 red, so all I have to do is do 3 plus 5 here. And then we're trying to find the total red in the bag, and we know that the total in the bag is 24. of green and red. So then this becomes 5/8 equals x over 24. So then when we cross multiply that, so we have 8x equals 5 times 24, divide by 8 on each side. So I get x equals 15. Okay, so that's how many red apples there are. And then you can check that, like, so then that would be 15 to 9, and then you can verify that, yeah, that reduces to 5/3, et cetera, et cetera. Okay. The ratio of union members to non-union members for a company is 5 to 7. If there are 312 employees total, how many union members work for the company? So they gave us union to non-union. So that's 5/7. They want to know, so how many union members work for the company? So we could do union to total. So we have 5 over 5 plus 7 would be equal to x over 312. Okay, so that's 5 over 12 equals x over 312. So we get 12x equals 5 times 312. Divide both sides by 12. So I get 130. Okay. So now these examples are just doing percentage problems using proportions. So these are really, I like this the best for story problems. So these basic sentence problems, you could go either way. Either that, just building the equation out of the sentence or using the proportions. So when I'm doing it with a proportion, so for number 8, I just get started with this, and then I say, I got my free space where I just write 100. I look at this and I see, 15%. So the 15 goes over the 100. And then for the left-hand side, I think is over of. So I see of 120. So that 120 goes on the bottom. And then what amount is? Well, we'll call that x. And now I just cross multiply and divide. So I have 100x equals 15 times 120. Divide both sides by 100. Okay, and I get x equals 18. 75 is what percent of 60? So now, when it's an unknown percentage with this, what will happen is it will give you the number for the percentage without a percent symbol at the end. You don't have to do any decimal place moving around. You just add a percent symbol on. With the other method where we convert the sentence into an equation, you have to, move the decimal point and add the percent sign at the end. This one, you just have to add the percent sign at the end, as you'll see. All right, so set up my proportion. I got my free space. It says what percent. So the number over the 100 is what we don't know. Okay, over here it's is over of. So of 60, 75 is, and then I cross multiply. So I get 60x equals 75 times 100. Divide both sides by 60. So I have x is what? Okay, so we get 45. And I need to remember to turn that into 45%. 16 is 80% of what number? Okay, is over of. So 80%, well, that 80 just goes over the 100. And then of what number 16 is. So 16 is going to go on top. X goes on the bottom. And then I can cross multiply. Okay. I have X is 20. All right, here's where the proportion technique for percentage problems really shines. So number 11, a book sold 34,300 copies in its first month of release. Suppose this represents 7.1% of the number of copies sold to date. How many copies have been sold to date? Round your answer to the nearest whole number. Okay, so we don't kind of clearly see what's going on with this. Now, with these story problems, we need to make sure that it's not saying some kind of percent increase or decrease here. I'm not seeing that. So we can just write the 7.1 over 100. Okay, now we have to do some critical thinking here. So it says 34,300 copies in its first month of release. And it says, suppose this represents 7.1%. So what it's saying is this 34,300 copies. So that's this word this. So the 34,300 and the 7.1 should be across from each other. Okay. And then how many copies were sold to date? That would be 100% of them, right? So the X should be across from the 100. So let's cross multiply. So 7.1x equals 34,300 times 100. Then we divide both sides by 7.1. So x is what? So I get 483,099. Okay. A house has increased in value by 29% since it was purchased. If the current value is $129,000, what was the value when it was purchased? Oh, okay. So we see increased by 29%. So we have to be careful with that. So we put our 100 there. Now, if it's increased by 29%, so that's going to be 100% plus 29%. Okay. Current value, that's the value now. So that's the one that has been increased by the 29%. So that 129,000 should be across from the 100 plus 29. And then what we're trying to find is what it was in the past. Okay, so we can simplify the right-hand side a little bit. before we start multiplying stuff. Okay, so cross multiply that, we have 129x is equal to 129,000 times 100. Divide both sides by the 129. Okay, so then I get x is equal to 100,000. Okay, and I'll just slap a $sign on that. All right, that is 51B. Okay, I hope this helps out. I hope this got you thinking about stuff. And if you have any questions, send me an IB Learn inbox message.